Good afternoon, everybody. It's nice to see that there's lots of people joining here. I like to run these sessions as quite interactive, so please do pop any questions in the chat as we go along, or feel free to pop and say you'd like to make a comment, as Andy said, and we can have a discussion as we go along. It's not meaning for me to sit here and give a lecture directly to you that you just have to sit and quietly listen. I'd like it to be more interactive if possible. So I've got some slides just to talk around and mention a few things about Aberystwyth and some of the work we're doing on astrophysics. And so maybe to give you a bit of an idea about what you might want to in the future for your studies and for your career and where things might take you. So it's just to give a little bit of a broad taste of what it's like to do astrophysics and what kind of things astrophysics can lead to. As Andy said, my name's Dr. Rachel Cross. I'm a lecturer here at Aberystwyth University in the Department of Physics. And Aberystwyth is one of those places that does look like this sometimes, but as we are with the inclement weather, it doesn't currently look like that. But I'm safe to say it does actually look like this. It's not been photoshopped. It is one of those places where it has a thing called the Aberystwyth effect, where once you've come here, you might not want to leave. And I'm one of those people that I got out for a few years, but come back to my spiritual home of Aberystwyth. So we're going to talk today about a little taste of astrophysics. So like I said, I'm a physics lecturer, so I teach a lot of the fundamental principles of this. My personal research is in materials physics, but also space instrumentation is what I've moved into as well. So I have an insight on the astrophysics from that side. And to join us today, I've also invited two of our current PhD students who did their undergraduate degrees with us in astrophysics, just for them to give a little bit of an insight on what it's like to be a student on that degree and maybe where they're going to, because they've gone into two different research areas, and where they're going to move to maybe next in their careers. So like I said, please pop any questions out as you're going along. I can't see the chat in the screen that I've got up at the moment, but Andy's there to shout out any questions. So this is what I want to talk about today. So I'm going to just introduce what astrophysics is, because it can be quite an abstract concept to people. People often as well think physics, what's physics? So astrophysics can seem that a little bit more exciting and different. So I'm going to say a bit of what it is. And then the kind of careers that astrophysics can take you into. I'm just going to mention a few of those and see what ideas you guys have as well. Then I'm going to touch a bit about planetary exploration, which is an area of astrophysics, and the kind of projects that we're working on here in Aberystwyth to give you a taste of what we're doing, working on things from the sun all the way out to Saturn. So you can think we're actually quite broad, and then some things beyond that as well. And then finally, we're going to bring in my two lovely PhD students, and we're going to have a little chat with them. So we'd like that to be a nice dynamic question and answer session. So please shout out any questions. Okay. So what is astrophysics? Is there anything that people think of? What do you think of astrophysics? So what words come to mind when you think about astrophysics?
First off,
can anybody pop anything in the chat and Andy will read them out?
Space, smiley face, and stars, space and stars, smiley faces, solar systems, the universe, planets, space, sea and planets, smiley face, and black holes, planetary exploration, Elon Musk, little curveball there, the physics behind the universe, interstellar, dark matter, space. I think the consensus is space, smiley question mark, isn't it?
So these are just a few words that came into my head when I think astrophysics, and I can see you've got a few there. So we've got astrophysics in the middle, and you can think, physics, telescopes, particle physics. Then you can think more fundamental, like electromagnetism, thermodynamics, theoretical physics. You'll find with astrophysics that there's a lot of programming in that. So I see on the chat before I joined that many people are studying computer science as well as one of their A levels perhaps, or at GCSE. So actually those programming skills are really important, and some of the PhD students will mention that they've had to get to grips with those as part of their work as well. Things like nebula and the Big Bang, so all those kind of things that we can think of when we think of astrophysics. that's because there's so many words, because it's such a broad subject. So physics itself can be broad, and we can think about physics that, being a really broad subject that encompasses all the mathematical and engineering, and then we can pull that down to being astrophysics. And it's this really broad branch of physics which thinks about the physical nature of the stars or the celestial bodies, and we're taking those laws and theories of pure fundamental physics, and then we're applying those to and interpreting the information that we can see from some astronomical observations. So they might be observations that we're making here on Earth, or they might be observations that we're making maybe from a satellite or a planetary exploration lander, for example. So we can say these are all the different things, and we can relate those together. So here I've just got in this figure just a few of the different branches and kind of the building blocks of astrophysics. And I always tell my students this, that you can think of physics to do that really exciting, groundbreaking stuff. There's like a pyramid of exciting things. You've got to lay the blocks of all these different topics at the bottom to build your way up. And that's kind of what you do on an undergraduate degree. In the first year, you learn all those building blocks. So you'll find that a lot of the topics are common across physics and astrophysics and some engineering degrees, and then they start to specialise as you move up through the degree system. So don't worry about when you're thinking about going to university, you know, oh, do I want to do this particularly niche little area of astrophysics? You might not have found your flavour yet because you've not been exposed to it, and those first few years at university expose you to those different kind of topics that then you can find your niche and move into it if that's what you wish to do later with research. But an astrophysics degree also gives you that excellent grounding in all the basic physics, which means you can move into a really wide range of careers, because physics is one of those very, very transferable degrees. So we've got things like classical mechanics, so that's things that you might have done already at school, so things like Newton's equations, Newton's laws of motion, and then expanding on those, you've got electromagnetism, so hopefully at school you will start looking at how, you know, your bar magnet with your little bits of iron filings and you're getting the shapes. You can then start to think, well, that you apply that to a planet, so you can apply that to Earth's magnetic field, so you can start to see how those fundamental concepts, you can expand those out onto these more big picture ideas. So I've got things like statistical mechanics, so looking at data sets, analysing those and looking for patterns. So that's like, if you're really into maths and you really like the mathematical theoretical side, you'll really like your statistical mechanics. Thermodynamics, so looking at the temperature of things and how temperature changes. So we can see that when we are maybe making our observations on remote sensing of temperatures, so looking at the temperatures of the sun, looking at the temperatures of planetary bodies, seeing how things are changing, we need to be able to understand those laws of thermodynamics. So that goes back again. Then you've got the more like kind of thing that you really more encounter at university, but the kind of sexy science. You've got the quantum mechanics, and we've got one of our PhD students, Sean, his project concerns quantum mechanics, so he can mention a little bit about that later. So that's what a lot of people think of when they think of the high level physics, they think quantum mechanics. So we need to learn those basics of that to think about the principles of understanding what we're observing. Then things like relativity, special relativity, particle physics, and got all these exotic different compositions that we may see in space, but then we're also looking at those basic building blocks that are, of atoms that are in space that we also have here on Earth. So we can apply those, our understandings here on Earth, out as we're going out in the solar system and even further. And that same goes with the atomic and molecular physics. So understanding how things join together, how things aren't there as well. So we can think about particle detection that we're doing, so you can apply experiments they're doing in CERN out to things that we're looking at in space and those kind of principles and recreating them. So it really is quite an exciting, broad field that you can get all these basics in, but then drill down into something that really captures your imagination. So some of the kind of topics that you might hear about, so just to cover a little bit of different terminology that you might come across. So you might hear about people who are doing things like solar studies, and Liam, the other PhD student we have joining us, his studies concern solar physics. so he'll be able to mention a little bit about that. So that's concerning things to do with our sun, our star. And then you've got, you expand that out to stellar studies. So that's saying we're concerned about our sun, but also the other stars. So how do those things apply out? Planetary studies, so we're looking at actual bodies in space. Then we're looking at atmospheres and ionospheres. So this could be looking at our atmosphere here on Earth. So how we're using different technology to monitor our own atmosphere, to understand that before we can then expand that understanding onto looking at the atmosphere on Mars, looking at the atmosphere on Venus and beyond. So then we can think how we can expand that understanding. In order to do all these amazing space missions and get out there, we need to build these instruments. So be that for ground-based observations, or be that for remote observations from space, from satellites, or be that from landers, we need to build those instrumentation. And that's something that we have a really big passion for here in Aberystwyth, and that's something that I've had a little bit of involvement in too as well, and I'll pop through to that later when we get to the relevant planet in my list. So we need to think about how we design and develop those, and to do that we need to have an understanding of the science. So we need to think how we're going to use that in our work. Then there's things like understanding fields and particles. So we need to understand gravitation, we need to understand magnetic fields, electric fields, understand them on Earth, understand them in space. Things behave slightly differently. And then we can go for the real big question type research. So that kind of like, but why kind of research. So looking at cosmology, and that's the study of the origin and development of the universe. So there's quite a few different like subfields that you can get into, and then this is just a tiny list of the ones that you could get. So you may have come across some of these already in your studies, and these are the things to have a think about. So like I said, you don't need to know that you want to be, particularly I want to be a cosmologist now. You might find something else that's like, wow, I never knew I wanted to do instrument design so much. And there's all these different kind of areas. You don't know what you don't know. So I'm going to kind of open it up a little bit again for some ideas from you guys on the chat, or if you want to shout out. What kind of careers do you think you could do with an astrophysics degree? And where do you think actual astrophysicists work?
So we've got first contribution, NASA astronaut, in labs, NASA, research in universities, scientists, CERN, professors, teachers, particle accelerators, universities, telescope labs, telescope work.
Yeah, so a lot of those job titles, they kind of like go with the actual, you know, being a professional astrophysicist, so being that scientist. So those are the people that have maybe progressed all the way through, done their GCSEs, A levels, their undergraduate degree, potentially a master's, and then they've done a doctorate, a PhD. So they've got their doctor in front of their name, which hopefully in a couple of years Liam and Sean will have their doctor in front of their name as well. And they're then going on to take jobs in those kind of fields. But there's nothing to stop you doing an astrophysics degree to then apply that to other industries as well. Because like I said, with physics, we've got all those excellent transferable skills. So it's a really good broad degree in a way to take, because there's so much you can transfer. When you go to a careers fair and you say, and they ask you what undergraduate degree, and if you say, oh, physics, most of the time they'll be like, oh, a physicist, because they know that you've got those transferable skills of being able to write reports, being highly numerate, good with information technology. We need to have all those skills to get a degree in physics, and we build those up in the degree. So here's kind of an example of just a little image of a few different ideas of what to do with an astrophysics degree, and obviously this is just a tiny selection. So a lot of astrophysicists go into things like meteorology, so looking at weather. You'll find a lot of people that are down at working for the Met Office and international weather observation stations. They've actually got physics and astrophysics degrees and geophysics degrees and things like that, because they've got those kind of transferable skills and they've got that data analysis. They can model things, they can understand the physical properties behind it, so they can make those connections. One of the things there that's very topical right now is you can go into being a climate scientist, because understanding our ionosphere and our atmosphere will help us understand how global warming is changing and how we can influence that, and how we can model that and predict the future and see where maybe we can correct things. A very obvious one for an astrophysicist would be to be an astronomer. So this could be an amateur astronomer who could go into and still keep up your astronomy. And there's loads of amateur astronomers that make fantastic contributions to academic work as well. So it's a nice thing that you can keep up in your own time, in line with another career as well. A nice topical one for my talk today about planetary exploration. We've got planetary scientists. So they tend to also bring in a little bit of geology as well into there, or some bring in a bit of microbiology as well. You may have heard of the title of being an astrobiologist. So that's looking at biology off the planet. So there are other exciting job titles that we can go to. One you might not have thought when I say precision agriculture, that seems a little bit maybe off-piste. You might be thinking agriculture, farming, but the future of farming is making the best use of our resources with the climates that we've got at the moment. So one of the things we can do is use the remote sensing skills that you acquire as astrophysics and looking at the interaction of radiation with matter, so looking at how light interacts with materials and detecting that, building instruments to monitor crops from unmanned vehicles, so little UAVs and drones. And then you can use the data to say, oh, looking at this field, this area needs some more fertilizer, this area needs some more water. So you can just give the resources where you need them. And that's something where we're going a lot more, bringing science into industry and making those kind of innovative connections. I've got then a few more like nanotechnology, research, obviously. Quite a lot of people who do astrophysics want to go into research, and I saw that on the chat that quite a few people said they wanted to do their doctorate, and that's great. The world needs more physicists. So yeah, that's really great to have that aspiration to go there and think that long-term view. Things like engineers in all different disciplines, like for satellite design and instrumentation. So there's really quite a lot of different areas that you can go into with an astrophysics degree. So I hope that's kind of confirmed to you. Thought, oh, what can I do with an astrophysics degree? Can I only look down a telescope? I hope that's maybe given you a few ideas that really the world is your oyster with a astrophysics degree, because you can have that wide range of career options and you're very desirable to industry. So that was just a bit about the careers. So now I'm just going to talk about kind of Aberystwyth's involvement in planetary exploration. And we've been, there's been a physics department in Aberystwyth since the university began. And we used to be down in this picture, that's my background. We used to be down there by the college by the sea. And that's Old College, that was the original university buildings. But then obviously we outgrew that and we moved up the hill instead. So if you come to Aberystwyth, you will get fit walking up the hill, but there are lots of buses and taxis. But yeah, the hill with the wind blowing on you, it's very bracing in the morning and you feel very grateful to get into your lecture room when you get there. But on a nice day, you have your benefits. So that's where we started. And from the beginning, we've always looked at particle detection, looking at cosmic rays, looking at all those kind of things. And the mesotron was actually detected and discovered in the basement of the old college here. So that's like a nice bit of history for you. And then when we moved up onto campus, we installed bigger equipment like a robotic telescope on the roof of the department, and we've had different wavelengths of lasers that we used to do for shooting up into the atmosphere to analyse the atmosphere. So we kind of moved on there. Then we moved on to rocket development, working with some of the sounding rockets for sending rockets into our atmosphere with instrument payloads, and in collaboration with other people, we've then moved off Earth and moved out. So it's a really nice thing to say, and it kind of blows your mind a little bit to think about it, but I'm surrounded by people who have worked on missions all the way from the sun in the centre of our solar system, away so far out to Saturn. So we've been involved in a mission on every planet all the way out to there, and that's like makes me quite excited that I can work for these people who've worked with diverse things like that. So here's our solar system in obviously a stylized view with our planets in there, because obviously we wouldn't be able to pop them all on the same scale. So when we think about our solar system, it's this vast area, and we look into the night sky, and with the naked eye we can often see Mars and Venus, and then we think, how much further are things? So, you know, with a home telescope and some of the ones that we have to loan students here, we can clearly now start to make pictures of Venus, really clear, and we can look out as far as Jupiter and get Saturn's rings. So we can think, how can we get there? And it's one of those fundamental questions that people often have, is because it's there, I want to see it and I want to study it. And that's kind of what physicists are. We ask those questions. It's like, it's there, I need to know about it. It's having that question attitude. So if you're one of those people who always ask the annoying why question, I would definitely recommend studying physics, because that's the kind of question attitude you need. So starting off with our star, the sun, these are some images on this slide. So I've got some nice images taken in contrast. So these are showing different UV and X-ray images, like false colour of the sun, that were taken by some of our researchers here in Aberystwyth. And we have quite a large solar physics group, and this is one of the main areas looking at the sun. So they look at things like the chromosphere, so the lower layer of the sun, because if you think it's this big hot ball of plasma and then it's got all these layers that we can define it up into. We can look at the corona, and you may have heard of things like coronal mass ejections, so when you get these solar flares and things knocking out satellites. So it's starting to understand and study these things, because the more satellites we're popping up into our orbit around our planet, the more we are exploring further. We need to think about not just our weather, if it's a nice day to launch from Kazakhstan or Cape Canaveral, is it a nice day to launch there in good weather conditions? Is it good space weather? So one of the things we do here in Aberystwyth is we look at space weather. So we look at the solar wind, and we look out at any flares and trying to predict those things. So that's kind of a really exciting thing. So you could say you could be a meteorologist for the Met Office, looking at whether it's going to rain on Tuesday, or you could be a space weather meteorologist, which it's quite a fancy title. But basically it's going to be a really big industry, and you can see the growth in the UK space industry. So it's a good area to go into. So that's kind of one of the things that we do here with the sun. We're also involved in a few specific satellite missions. So I've got a couple of pictures there of a few ones that we got. So we've got things like Stereo and Solar B. So these are satellites, and they're trying to make 3D images. So they're sending out multiple satellites so that they can take photographs and then build up a nice 3D image. And we have a really cool 3D model of the sun in the department that we can rotate in a virtual reality, which is really quite cool. And then we've got new projects coming online, like Sulis, Sulis is named after a Celtic goddess of like the sun, so that's the name of the project. And these are going to have like small satellites flying in formation to study the corona and to study the sun. And then a new one called Punch as well, which is another polarimeter, looking at the corona and the heliosphere. So looking again at all those different layers of the sun. So trying to find out as much as we can about our sun and how that affects our life on Earth. So people might think, when you think astrophysics, it's very out there, concerned with space, but actually a lot of the things that we learn from our studies there can apply again back down here and help us, and it helps our daily life. Moving along out from the sun, we've got the smallest planet, the least explored one, Mercury. It's least explored because it's really hard to get to, because it's so much closer to the sun. If you try to slingshot your satellite or your lander towards it, the sun's gravity just wants to pull it away. So it's quite hard to get to on that front. And we're involved in this mission called Bepi Colombo. And it's going to be Europe's first mission to actually get to Mercury, and it's due to arrive in a couple of years. It launched a few years ago. And there's people here in Aberystwyth University, AU, and we're modelling the composition and the surface of the exosphere. So that kind of like atmosphere around it and going out into space. And then we can try and predict maybe what the lander will see on arrival, so how we might compensate equipment and instrumentation. And the picture there gives you an idea of a size scale. So those kind of poster board kind of barriers, they're like about the height of a person, so they're just under 2 meters high. So you can think that's the size of the satellite that then goes up on the rocket and shoots off into space. When it gets out there, as you can see from the picture on the right, it unfurls its solar panels to get it round into the correct orbit. Then moving a bit nearer to us, we've got Venus, our second planet from the sun. and we've been involved in a mission called Venus Express. So that is looking at the atoms in the top of the atmosphere. So we're actually kind of like sniffing for almost like atmospheric dust. So we're looking to see what the atmosphere is going to be like. So we look after the detectors that are hunting for those atoms in the top of the atmosphere. And Venus has got a very different environment to Earth. So it's really interesting to see the dynamics of how we think that maybe water has evolved and been stripped off Venus. And could that possibly be our fate on Earth? Then we've got our place, Earth. You might think astrophysics, I'm just concerned of space. Hopefully now you might think, actually, I can do things a bit closer to home. And a lot of that is remote sensing, so controlling instruments from the ground. We've got the RAL space radar array just out of Aberystwyth, just next door to us, that we use as well. And then we also have a range, as you can see in the figure there, of some solar physics people, so using solar scopes, and they use those kind of things for their research projects as undergraduate students. So these kind of things aren't reserved just for PhD students and postdocs. At university, you can get your hands, and certainly at Aberystwyth, we can get our hands and do projects that are research based with actual researchers that are working on these things. And then one of my favourite pictures there is some students up in the high Arctic in Svalbard. We have a degree scheme that's a master's course in space and planetary physics, and you have an opportunity to do your second semester in Svalbard in the Arctic Circle there, where you learn how to use a shotgun to fend off polar bears and ride skidoos and all those kind of things, and also observe the ionosphere and observe the northern lights because of the excellent locality that you're in there. So that's really exciting. I've just mentioned throwing in not a planet, our moon, but we've been involved in quite a few missions to the moon, because obviously it's the nearest thing to us, so it's the thing we've most explored as human beings. So we've been involved in a couple of missions there where we've been looking at X-ray fluorescence off the moon, and again some remote sensing and modelling of it. A colleague looks at lunar impact flashes, so actually where that little X is on the moon, that's where he has discovered the first one observed from the UK. Of a lunar impact flash, and so he believes that that's a meteorite striking the moon and causing a flash of light. So that's really interesting, because from the colour of the light you can use spectroscopy to find out the composition. So it's a way of finding out the composition on the moon without going to all the expense of going to it. So that's another kind of flavour of a mission. The one that's probably hottest right now that everyone knows about is Mars. So we've been involved in lots of missions to Mars. So the Mars Explorer that launched Beagle, that we thought had lost, but actually we recovered. And most recently we're on ExoMars, which I'd invite you to come and have a look at our website about some of our things for ExoMars, and I popped a link at the end of the presentation as well. Because we built this awesome outreach rover, which is a life-size model of the ExoMars rover. And we've been involved in producing these items, which are the PanCam calibration items. So we're calibrating the cameras, the panoramic camera. So that is this little camera up on top of the mast that's on the figures. So we're actually calibrating that. So it's really exciting. Every side image that they take on Mars is going to have been through an Aberystwyth processing pipeline to correct that image and to calibrate it by taking a picture of something that's actually been built in the workshop next to where my office is. And I've touched some of the things. Obviously they've been cleaned since, but it's really exciting that we built those here in Aberystwyth, and they're part of that mission. And you can see there, there's a chap Ariel standing in front of a rover. That's a mock-up of the Airbus rover who were building the chassis for the ExoMars rover. And he was actually one of our undergraduate students that got to work on this project. And then he worked he's now a PhD student as well. So he's completely got the bug for ExoMars and calibration. Almost near the end there, so we've got Jupiter. We're looking at Jupiter's icy moon. So we're not actually going to Jupiter because it's a gas planet and we're not going to be landing on there. But we do have looking at satellites in orbit. So Jupiter's got a really high radiation environment, so it's really damaging to electronics. Anyone who's for example, lost your card, had your card demagnetized by going near a medical scanner, you can think what it does of something like Jupiter to our space instruments that we spent a fortune flying out there. So we're actually working on some of the radiation models and looking after those detectors for radiation shielding here in Aber. And finally, with the planets, we've got Saturn. So we were involved in the Cassini mission, which recently finished, and it crashed into the planet to get some final data. And that gives you an idea of the context of these missions. It was over a 20-year mission from launch to it smashing into the surface. And we were involved in, again, detectors and picking up signals from that. And finally, out of our solar system, we also look a little bit further afield. So one of the fields, and this is what Sean, his PhD's areas is astrochemistry. So looking using high-level quantum chemistry to kind of understand things that are further away. So characterise the atmospheres of exoplanets you might have heard a lot about in the news, and hunting for planets by their spectral signatures. That's kind of thing that you would use astrochemistry for. So, and again, really cool title for what do you do? I'm an astrochemist. So it's one of those things. So what is it like, though, to study an astrophysics degree? I'm a little bit older now and can't quite probably hazily remember what it was like to be an undergraduate student as much, but I have brought along today two lovely students who are both studying their PhDs. So I have Liam Edwards and Sean Donnelly. They both did their undergraduate studies in astrophysics, and then they stayed on to do their masters, and then we couldn't get rid of them because they loved it so much, and they are doing their PhDs with in two different areas. So what I'd like to do now is probably stop sharing my screen and invite Sean and Liam to pop their mics and their cameras on, and we can just have a little chat.
Perhaps we should kick off with a question from Max, Sean and Liam. In university, what extra opportunities to engage with practical projects and experiments are there? So could you give us a bit of a flavour of practical projects and experiments undergraduate level astrophysics?
Yeah, so one of the undergraduate projects that I did in my second year was we got to use one of the telescopes that we have, so one of the robotic telescopes that we have in the department. So just outside of Aberystwyth, actually about a mile out, we have a robotic telescope that's housed in a sort of dome. We also have one on the roof, like Rachel mentioned. And one of the sort of the 6-week projects that I got to do in my second year was to use that telescope to take pictures of the moon, and then try to basically do some science with the data that we got out from that. And then also I know of some of the other second year projects that people can do. They can use the solar telescopes, like Rachel mentioned, to take pictures of the sun, or to basically do a small project on that. And then once you get into your sort of third and fourth year projects, then they take the entire academic year, more or less, and there's a lot of opportunities for people to get their hands on with some really cool bits of kit, actually. I myself chose to do some more theoretical ones because I prefer my work done on a computer, but no, there's loads of opportunities to do some really cool, but also some really wacky experiments as well.
Is that the same for you, Sean? Or did you go down a very different route from Liam?
Not particularly, actually. When I did my second year, we had there was like all these list of projects that we could choose from, and me and Liam actually ended up choosing exactly the same projects, despite the fact we worked in 2 different groups. But the nice thing about it was we were able to take different spins on it. So, for example, one of the projects that we did, we were focusing on the on coronal mass ejections from the sun. Liam's group took 1 or 2 of those and looked at them individual events in depth, and would do some sort of image work on that to sort of see how they evolve over time. The group I worked with, we took it from more of a sort of just a data analysis perspective. So we took a catalogue of thousands of events over the course of 1 or 2 decades, and analysed all the data from those to see how fast CMEs were, how like sort of the size of them, their intensity, how frequent they were, when they mostly happened, when they didn't happen. So during differences like when the sun's more active during solar maximum and when it's less active during solar minimum. So yeah, you can, even though you'll find that there is sort of, you know, there's so many projects you can do. There is so much you can do, but then you can take a single project that's advertised and put your own spin on it. And that was one of the things that I found was a lot of fun when I was doing my undergraduate degree, because it gave us the opportunity as second years to think, well, what can I do to give it my own personal spin on this? And it gets you, for anybody thinking of doing research, it was one of the things actually that really got me into wanting to do research. Sat there at a computer programming out huge pieces of code in Python, you know, getting stuck on it one minute, solving it the next, and you find that it ends up being a lot of fun, and it gives you that taste of what it's like to be a researcher. But then moving into third year as well, there's lots of projects, undergraduate projects that you can do that do the same sort of stuff, as well as just sort of second year. But these third year ones are there for your dissertation, for example. That's at the end of your degree, unless you choose to go on to, say, do the master's scheme, which Liam and I did, which is you get to do that all over again. You get to do two, and again, it's the same sort of thing, but this time, you know, it's work that, if you really put your heart into it, it's work that could even find itself being published. So myself and my supervisor at the moment are working on, there's a few undergraduate projects for the third and fourth year, like the master's year, where we're taking some quantum chemistry, and we'll hand over the data to some of the undergraduate students, and they'll get to do their work on it, and then we'll compile all that together, and hopefully at the end we'll get to publish it. So I saw one of the questions was saying about getting involved in research as an undergraduate, and you can if you know, get the opportunity to really work and have research that's published out there before you've even finished your degree, which is quite cool.
What about?
Yeah, I mean, definitely you can get involved with. Sorry, right.
Go ahead,
definitely
Rachel,
you can get involved with current missions, and in my slides that was one of the chap that was stood there in front of the Airbus rover. He was actually in the Atacama Desert conducting a field trial, and he works on with the ExoMars mission and our investigators as part of his like what Sean said, the third year project. So he chose a project to work with that, and then there are third year projects to work on some of these different missions that I've touched on in my presentation, especially some of the solar ones. You can work on those kind of things. Like we have lots of projects on calibration and things like that. So working with data from these missions with supervisor who've worked on those missions. So yeah, definitely opportunities to get involved in actual research. That's the point of the third and fourth year projects.
Cool, thanks, Rachel. What about somebody looking to go into astrophysics at university? What sort of, there's a couple of questions about preparation. Are there any computer programs or coding languages that would be useful before going into astrophysics? And there was another question about opportunities to improve an application to university, maybe some, you know, pre-experience in astrophysics. I wonder if either of Sean or Liam could answer that.
For programming languages, for a start, as a uni, we sort of settled on Python as like sort of the primary coding language. So moving through your undergraduate degree, you'll get the opportunity to use a lot of Python. That's what I tend to do a lot of what I prefer to do a lot of my work in. It doesn't always work out that way. For example, one of the programs that I use for my work it was designed in the 1980s. It's been updated through the years, but it was still written in a programming language from the 80s. So when I code my files to put into that, I have to code them up in quite an old programming language called Fortran. But you don't necessarily have to come in with the experience.
Not that old.
I think it's Fortran 90. But you don't have to have any specific skills coming in. The uni is really good at teaching those through yourself. I had literally no experience whatsoever in programming before I started my degree. So that, you know, the uni does, they give you what you need.
And Liam, beyond programming, maybe some thoughts about preparing yourself for a degree in astrophysics?
Well, certainly one of the things that I would advise people to do is, well, it's quite difficult to do now, sort of these days, obviously with coronavirus and stuff. But outreach stuff, so basically doing a lot of this type of thing. Unfortunately, from where I'm from North Wales, there isn't really a lot of science outreach in general being done there. But if you come from a part of the world where you can sort of get involved in doing some outreach activities, that definitely helps an application for coming to university. And then also you find that when you do outreach events, sometimes you might be involved in an event where you're talking about a subject, or you're helping out about a subject that you don't really sort of have an idea of what that subject is actually about. So you have to do some reading up about it, and so it helps to basically just expand your sort of knowledge if you do outreach. And then also it shows that you are that you're willing to sort of to put yourself forward and do that extra work to improve your application.
Thanks, Liam there. What about this question from Dave? Cooperative working with other universities like Keele, other astrological groups and telescopes, so linking up with other sites. Any insight on that?
Yeah, obviously we're a small university on the west of Wales, but space is very big, so the distance between us and NASA and ESA headquarters in that scale is quite small, and we work very internationally. So none of the missions we work alone, and we work in cooperation with lots of other universities. For example, the work that we're doing, the panoramic camera for ExoMars, we're working with the Mullard Space Science Laboratory, University College London and Birkbeck. So dependent on the missions, different groups, because I know both of you guys, Liam and Sean, that you've worked with, your research works with other university groups as well, doesn't it? And central facilities. As the telescopes are not owned by a university, there tend to be central facilities that we bid for on these kind of instruments.
Yeah, for example, like we, myself and my supervisor, but the ExoMar group that Rachel mentioned, that's spread all around the world now. It started out in at UCL in London, and over the sort of last few months, I've had the opportunity to work with people who are in that group, and they're in places like Prague and Sydney, and I feel sorry for those guys because most people are in Europe, so the people in Sydney are up at 3 a.m. while we're all here enjoying the sunny weather, and they're stuck in dark rooms. But yeah, you get I work with people from all over the world, which is a lot of fun. You meet people that you just didn't think that you'd have an opportunity to interact with, and yeah, it's kind of sobering thought by the end of it all.
Thanks, Sean. There was one more question about the general kind of life on campus at the moment under lockdown, and we've also got Robin here, who's representative of student recruitment at University of Aberystwyth. Just generally, your thoughts, maybe Liam and Sean and Robin, on student life at Aberystwyth at the moment?
I think Liam and Sean are probably best placed to answer those questions, but I mean, we're quite lucky in Aberystwyth. We've been able to have in-person teaching as well as online teaching. So we recorded a lot of our lectures anyway. So a lot of our lectures were online. So switching to online was business as usual for us. But then because of the safety measures that we put in place, and where we're lucky enough to be situated in Wales, we were able to have in-person teaching, socially distanced, of course. So we're fairly happy that there's not been too much of an impact on like regular life. It's not as normal, of course, but not too much of an impact for students at Aberystwyth, luckily. But I'm sure Liam and Sean have better kind of experience of that.
Yeah, obviously it's changed for everybody. Everyone's had sort of everything's had to change for everyone to some degree. But for the most part here, as a student, of course, I find myself working from home more so than I do sort of on campus, but the university's been really supportive. Yeah, one of the things that I'd always say about Aberystwyth University, for example, is that with the lecturers having such normally they'd have an open door policy where you'd be able to go in and knock on their office doors, but you can't do that at the moment because the whole social distancing stuff. But dropping them an email, and they're always more than happy to get back to you. And always happy to chat online and using Zoom or Teams or whatever your preferred method is. But for me personally, like Robin said, it hasn't really changed too much. There's obviously a lot of the activities that you wouldn't normally be able to do, like the social activities, like societies and things. But that's temporary, and that'll all pop on back. So for the most part, it's not changed too much for me.
Thanks. Question from just a few more astrophysics questions, just to finish off. If you don't mind hanging around for another 5 minutes, guys, just to finish these some of these questions. I don't understand this question, but maybe you will. What is your opinion of the Artemis hot fire rocket test?
Yeah, it's really cool, the idea that you can reuse rockets and also have like larger payloads and be more conservation of the fuel. It's quite exciting to watch that. My little boy really liked watching that when we were watching those the demonstrations live. The fact that you can reuse these things, because obviously space things are. The space in space is going to be a premium soon, with the amount of junk that we've been flinging up there and abandoning. So it's nice to think that there's a way to reuse that. I saw some questions on there about, like, is it difficult to get into astrophysics if you take physics or natural sciences? Certainly not, because like I said at the start of my talk, you need all those building blocks of electromag and thermal physics and all those kind of things. And if you take a physics degree, the nice thing that is common across physics degrees, but particularly here in Aber, I can speak about, and that I know firsthand, is that, like, our first year is generally core and common. So then as you decide what you want to do, you can change degree schemes. So we are quite flexible. So you might start on a physics degree or an engineering physics degree, and then you might change to an astrophysics degree, or vice versa, depending on as you learn more and your interests change. And then certainly you can always bolt things on with interesting master's courses and then PhDs. I know lots of people who've done the PhDs in who've done the undergraduates in astrophysics, who've done PhDs in materials physics and vice versa. So as long as you get those fundamentals down, the door is open to you.
Quick question here about dual honours as well, Rachel.
Yeah, we do joint honours. We've got a couple of degree schemes, so you can do physics with maths and you can do physics with computer science, and then we also have a major minor of physics with education, which is specific for those kind of people who want to go into teaching and get that kind of head start. So they're the only joint schemes we do. We do space science robotics, which is a unique degree to Aberystwyth because of our heritage in that front, which is kind of like all the astrophysics parts and the computer science robotics parts melded together into a degree, if you can imagine what that is. But if you'd like to find out more, it's all on our website, and we have the upcoming virtual open day as well.
Thanks so much, Rachel. I think we're going to have to bring it to a close because we're about 5 minutes over time. But if there are any burning questions, can people contact the department of Aberystwyth?
Yeah, so our email address, I stopped sharing my screen, but it's phys@aber.ac.uk. So you can contact the I can just pop up on I can pop it in the chat.
Cool. Thank you so much, Rachel, and
thank you to contact us there.
Great. We'll bring it to a close then, if that's okay. Unless there's any final thoughts from Sean, Liam, or Rachel.
Just thank you very much.
Yeah,
thanks for coming along, guys. Thank Sean and Liam for joining me on this, because it's really nice to have their perspective from their research.
Absolutely, that's exactly what I was going to say. It does really bring the sort of the recent student experience alive for people, and so thanks so much for your time, guys, and thanks Dr. Cross as well for your time, and thank you everyone for being involved in today's chat. The session has been recorded, and I think there'll be a link sent out in an email after this, so if you do know anyone who was unable to get along today, then you can send them that link as well. Thanks ever so much for the to the University of Aberystwyth for hosting today, and yeah, if this sort of session has been interesting to you, then you can look on Channel Talent's website for other similar style insight sessions and taster sessions.